Hi, this is section 9.8, determinants. In this section, we will evaluate the determinant of 2 by 2 and 3 by 3 matrix, and we'll use Cramer's rule to solve a system of equations. So far, we've learned how to solve systems of equations in 2 variables and 3 variables using multiple methods: substitution, addition, Gaussian elimination, using the inverse of a matrix, and graphing. In this section, we'll learn another strategy for solving a system of equations. Evaluating the determinant of a 2 by 2 matrix. A determinant is a real number that can be useful in math because it has multiple applications, such as calculating area, volume, and other quantities. We're going to use determinants to reveal whether a matrix is invertible by using determinants to reveal whether a matrix We're going to use determinants to reveal whether a matrix is invertible by using the entries of a square matrix to determine whether there is a solution to the system of equations. A square matrix is invertible if and only if its determinant is non-zero. One of the more interesting applications is their use in cryptography. Secure signals or messages are sometimes encoded in a matrix. The data can only be decrypted with an invertible matrix and the determinant. So, if the determinant is non-zero, then there does exist one solution. Okay, so if you calculate the determinant and it's not zero, then one solution does exist. If the determinant is zero, then there could either be no solutions or there could be infinitely many solutions. But that would mean that the system is invertible, is not invertible. So this lets us know how to find the determinant of a 2 by 2 matrix. The determinant of a 2 by 2 matrix given the matrix A, B, C, D is defined by A times D minus C times B. Notice the change in notation. There are several ways to indicate the determinant, including the determinant of A and replacing the brackets in a matrix with straight lines. So if we want to find the determinant of this 2 by 2 matrix, we're just going to do 1 times negative 2. Whoops. Get a color out here. We're just going to do 1 times negative 2 minus negative 4 times 5. So the determinant of A will equal 1 times negative 2 minus negative 4 times 5. So that will be equal to negative 2 minus negative 20. Which equals 18. So just using what we learned on the previous page to find the determinant of a 2 by 2 matrix. Let's find the determinant of this 2 by 2 matrix. We'll just do 3 times negative 2 minus 2 times 0. 3 times negative 2 minus 2 times 0. Negative 6 minus 0 is just negative 6. Solve the following equation involving a determinant. So x times x plus 4 subtract 2 times 1 should equal 19. So x multiplied by x plus 4 minus 2 times 1 should equal 19. So x times x is x squared plus 4x minus 2 should equal 19. And let's go ahead and just move the 19 over and then just solve this by factoring. So minus 19 on both sides. So I'll have x squared plus 4x minus 21 equals 0. X times x. 7 and 3. Positive, negative. So x plus 7 equals 0. X minus 3 equals 0. So x equals negative 7. X equals 3. All right, finding the determinant of a 2 by 2 matrix is straightforward, but finding the determinant of a 3 by 3 matrix is more complicated. One method is to augment the 3 by 3 matrix with a repetition of the first two columns, giving a 3 by 5 matrix. Then we calculate the sum of the products of entries down each of the three diagonals, upper left to lower right, and subtract the product of the entries up each of the three diagonals, lower left to upper right. This is more easily understood with an example. So let me just show you how we would do this. So let me go ahead and I'm going to use black. So given them the 3 by 3 matrix, let's find its determinant. We're not going to use a calculator. So we have 4, 4, negative 1, 1, 0, 1, 2, 2, 4. And I'm just going to take this column and rewrite it. So I'm going to have 4, 1, 2, 4, 0, 2. And now what I'm going to do is I'm going to take this, and this, and I'm going to sum those products. So I'm going to have 4 times 0 times 4 plus 4 times 1 times 2 plus negative 1 negative 1 times 1 times 2. Minus, and then maybe I'll do these other ones in a different color. So now I'm going to look at these ones right here. So that's going to be 4 times 1 times 4 plus 4 times 1 times 2 plus negative 1 times 0 times 2. So this is going 4 times 0 times 4 is 0 plus 4 times 1 times 2 is 8 plus negative 1 times 1 is negative 1 times 2 is negative 2. So that side is equal to 6. This side, 4 times 1 is 4 times 4 is 16 plus 8 minus 0. So we have 6 minus 24, which is equal to negative 18. And you could check that on your calculator by plugging that matrix in, the 3 by 3 matrix, and under math you can find the determinant of that just to check your work. Now there is another way. This is actually the easier way to find it, but there is another way to find the determinant of a 3 by 3 matrix And there is one problem in your homework that actually has you do that. So I want you to kind of be familiar with it. It's called the method of cofactors. And you do have to do one like that. To calculate the determinant of a 3 by 3 matrix, you multiply each element in any row or column of a matrix by its cofactor. Okay? The sum of these products is equal to the determinant. And the cofactor is equal to -1 to the I plus j times the minor of I and j. Okay, and so the minor ij is equal to the determinant obtained by deleting the ith row and the jth column. And this is much more easily understood with an example. So I'm going to show you the problem that they give you in the homework. Okay, so suppose we wish to compute the determinant of this 3 by 3 matrix by cofactor expansion on row 1. So sometimes they'll ask you to do it by row 2 or row 3. Okay, so we're going to do it by row 1. So what you'll do here, so the determinant of A is going to equal, so we're going to, it'll be 1, because we're going to use this row 1. So it's going to be 1. Now let me just go ahead and write down that the cofactor, remember, is equal to -1 to the I plus j multiplied by the minor mij. Okay, so we're going to have -1 multiplied by -1. Now notice that is in row 1, column 1. This number 1 here is in row 1, column 1. So that's going to be 1 plus 1. And then the minor is determined by eliminating this column and this row. So that's going to leave the matrix 1, -3, 0, -3. So that 2 by 2 matrix, the determinant of that matrix. Plus, now, let me just get my eraser here. Or not. So now we're looking at this -2. So plus -2 times -1. So now we are in row 1, but column 2. So it's 1 plus 2. Now we're eliminating this column and this row, which leaves the determinant of the remaining 0, -3, 0, -3. So we'll take the determinant of that. Plus now we're looking at this element right here. The 5 multiplied by the cofactor -1. So now we have row 1, column 3. So that's 1 plus 3, -1 to the 1 plus 3. Eliminating this column and this row, we'll be taking the determinant of 0, 1, 0, 0. Okay? So let's just go ahead and clean this up a bit before we plug it in above. So this will be the determinant of A will be equal to, well, negative 1 to the 1 plus 1 would be negative 1 to the second, which is just 1. And 1 times 1 is 1. So we'll have 1 to the 1, negative 3, 0, negative 3, plus negative 1 to the third power is negative 1. Negative 1 times negative 2 is positive 2. To the 0, negative 3, 0, negative 3, plus, now we have a negative 1 to the fourth power, which is positive 1, times 5 is 5, to the 0, 1, 0, 0. So that's what you plug in here. So you'd have 1, 1, negative 3, 0, negative 3, 2, 0, negative 3, 0, negative 3, 5, 0, 1, 0, 0. And so now we can find the determinant of A. And so just notice that now we're going to want to this subtract this, this subtract this, this subtract this. So 1 multiplied by negative 3 minus 0 plus 2 times zero minus 0 plus 5 times 0 minus 0. So the determinant of A is just going to be 1 times negative 3 plus 2 times 0 plus 5 times 0, which is just going to equal negative 3. Okay, so I hope you were able to follow that. There is a video in the homework as well that you can watch as well. But it is, you can see, a lot more complicated to find the determinant of a 3 by 3 matrix. Okay, given this matrix, let's find the determinant, and I'm just going to use the method that we used once before. And once again, if you understand how to do this, you can just skip along. You don't need to watch this video as well, but I'll go ahead and do one more example. I'm going to get black, and I'm just going to do it like the earlier one I did, negative 3, 3, negative 3, negative 1, 0, 2, 0, 4, negative 2. I'm going to repeat the first two columns, negative 3, negative 1, 0, 3, 0, 4. Let me get a new ink color. I'm summing these products. Negative 3 times 0 times negative 2 plus 3 times 2 times 0 plus negative 3 times negative 1 times 4. And I'm writing too big, and I'm going to run out of space, which isn't good. And then I'm going to subtract. Three times negative 1 times negative 2 plus I need to write smaller. All right, so I have negative 3 times 0 times negative 2 plus 3 times 2 times 0 plus negative 3 times negative 1 times 4. So that's going to be 0 plus 0 plus 12, which is just going to be 12. Minus, and now I'm going to have 3 times negative 1 times negative 2 plus negative 3 times 2 times 4 plus Negative 3 times 0 times 0. Negative 3 times 0 times 0. So this will equal 3 times 2 is 6. That's positive. Plus 4 times 2 is 8. 8 times 3 is 24. Plus negative 24 plus 0. So 12 minus negative 18. Because 24 minus 6, that's negative 18. And so this is going to become positive. So is that equal to 30, I believe? Hopefully I haven't made any mistakes there. We can check it on a calculator. All right. So now we'll introduce a final method for solving systems of equations that uses determinants. This is known as Cramer's rule. So this technique dates back to the middle of the 18th century, and it's named for its innovator, the Swiss mathematician Gabriel Cramer, who introduced it in 1750, 2 years before his death. Cramer's rule will give us the unique solution to a system of equations if it exists. However, if the system has no solution or an infinite number of solutions, it will be indicated by a determinant of 0, as I discussed earlier in the slideshow. All right, so this is how we're going to find x and y given a system of linear equations, ax plus by equals c, and another one, ax plus by equals c. Okay. So notice here we have x equals d sub x of d, or divided by d, the determinant. And then y is going to equal d subscript y divided by d. So if we're solving for x, the x column is going to be replaced with the constant column. And then if we're solving for y, the y column is going to be replaced with the constant column. Okay? So let's just go ahead and do an example of this. Okay, so let's use Cramer's rule to solve the system. Okay, so x is going to equal d subscript x over d, and y is going to equal d subscript y over d. Okay, so, and then there's a 1 here. Okay, so we can find d. So d, we're going to find the determinant of 1, negative 6, 3, 2. So that's going to equal to 1 times 2 minus negative 6 times 3, which is going to equal 2 minus negative 18, which equals 20. So that's what d is equal to. Now for d subscript x, okay, so now we need to replace the x's with the constants. So we will be finding the determinant of negative 5, 5, negative 6, 2. So that's going to be negative 5 times 2 minus negative 6 times 5, which is negative 10 minus negative 30. Which is also equal to 20. D subscript y, the x's stay in place. That's the 1 and the 3. The y column is replaced with the constants. We have 1 times 5 minus negative 5 times 3, which is 5 subtract negative 15, which also equals 20. Okay, so x is going to equal d of x, which is 20, over d, which is 20, which equals 1. And y equals d subscript y is 20, over d, which is 20, which also equals 1. So x equals 1 and y equals 1 in this example. And I believe this was the only example I gave you of this. Okay? So that's the end of the slideshow.